Okay, today we're going to look at charging and discharging capacitors. So what happens with a capacitor? As soon as you put it into a circuit with a power supply, the charges start building up on a capacitor. And when the charges start building up on the capacitor, the charges available in the circuit start to decrease because they get basically stuck on those capacitor plates. So as time goes on in this circuit, more and more charge will get built up on the capacitor and less charge will be available to flow around the circuit. Now, as the charge builds up on the capacitor, that means the potential difference across the capacitor will also increase, and the potential difference in the circuit will start to decrease. So, in this example here, and I'm going to show you the experiment later, we've got a circuit with a power supply, an ammeter, a resistor and a capacitor in parallel. We're measuring the voltage across the capacitor and the current in the circuit. So what we do is we'd maybe take every 5 seconds, we'd take the current in the circuit and we take the voltage across the capacitor. Now, bear in mind what I just said. So when we've got a capacitor in a circuit, the charge starts to build up on the capacitor, which takes charge away from the circuit itself. So the current in the circuit would, over time, would start to decrease because there's more and more charge built up on the capacitor and less charge in the circuit, and we're measuring the current in the circuit. The voltage across the capacitor, however, remember when I said that if we increase the charge across the capacitor, if the charge starts building up across the capacitor, the voltage also increases across the capacitor. So the voltage across the capacitor, which we're measuring here, would start to increase. And as time goes on, the voltage across the capacitor will increase more and more until it reaches the total voltage of the circuit, which is the supply voltage from the battery or the supply that we have used. So if we were to graph these, and I've drawn them already because it took me a little while to draw them anyway. If we were to graph the current against the voltage, which is this graph here, we'd see that the initial current is the initial charging current, which would just be the supply voltage divided by the resistance in the circuit. Because at the very start, the capacitor has zero charge across it. So you can basically ignore the capacitor at the very start because it doesn't really do much. So the initial charging current is just the voltage, the supply voltage divided by the resistance in the circuit. But very quickly, that capacitor starts getting charges built up on it. So the current in the circuit starts decreasing decreasing with time until it eventually gets almost zero, pretty much zero. We can, to all intents and purposes, we can say it reaches zero. But it takes a curve, it takes an exponential curve. So it gets closer and closer to zero. If we were to plot the voltage across the capacitor versus time, then we can see, which is this circuit here, which is this graph here, sorry, then we can see the voltage across the capacitor starts off at zero because right at the very start, the capacitor has zero charge across it. But as the charge starts building up on the capacitor, the voltage across the capacitor starts increasing until it reaches the supply voltage. And it can't get any higher than the supply voltage because it isn't supplied with any more voltage than that. It can't access any more voltage than that. But its highest voltage across the capacitor will be the supply voltage of the battery or the supply. Now it says here, what effect does increasing both the capacitance and the resistance have on charging time? Now we did talk about this briefly at National 5, but I like to think of it in terms of a bucket being filled with water. So if you increase the size of the bucket, then it takes longer for it to fill. So if you increase the size of the capacitor, it takes longer for that to get charged up. The resistance, I think of it as flow of water. So obviously the higher the resistance, the slower the flow of water. So if you slow down the flow of water, it also takes longer for that bucket to be filled. So increasing the capacitance and increasing the resistance would both increase the charging time. I'm going to stop there and show you the experiment of this. But the important thing to remember here is the current starts off high. You can work out what the initial current is by doing the supply voltage divided by the resistance, and it decreases with time. because more and more current gets stuck on the capacitor, less is free to move. The voltage across the capacitor starts off 0 when it has 0 charge across it, but as the charge starts building on the capacitor, the voltage across the capacitor increases until it eventually reaches the supply voltage.